Hey Bobcats, today we're going to represent and organize sample spaces for compound events using arrays. So we're going to get started. You may want to pause it real quick and get your notes set up, and then you'll be ready to roll. Okay, instead of starting with definitions, I'm just going to start with some examples so that you get an idea of what compound probability is and also what arrays are. You've actually been using arrays since elementary school, but you may not remember that is what they are called. Okay, so let's take a look at an example first. We're going to use an array to list the possible outcomes of tossing two coins at the same time. Okay, so far what we've been doing is we've just been doing one coin. Okay, it's either heads or tails. But if I were to add another coin in that and toss both of them at the same time, how many different possibilities are there in our sample space? Well, let's take a look. You could get heads, 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 tails, or tails, heads, or tails, tails. Okay, but let's actually show how that can be represented in an array. So an array is just a way of organizing things. Like multiplication charts are an example of an array. Now your array does not need to be perfect, but you know, I'm just a perfectionist, so I like to have all my lines be perfect. But you do not need to do everything perfect like I do. And anytime during this video, if you feel like you're getting behind on note taking, no big deal, just pause it and catch up. That's the beauty of having a recorded lesson, right? Okay, so we're gonna have the first coin up here. So we're gonna have coin 1 right here. And then coin 2 over here. So here's coin 1, here's coin 2. So coin 1 can either be heads or tails, and coin 2 can either be heads or tails. So coin 1, so if coin 2 is heads, then coin 1 could also be heads. So we're going to abbreviate this HH, saying that coin 1 is heads, coin 2 is heads, so the outcome is heads, heads. Now if coin 1 is tails and coin 2 is still heads, then we have tails, heads. Now let's say that now coin 2 is tails and coin 1 is heads, so heads and tails. And now let's say that coin 1 is tails and coin 2 is tails, then you get tails, tails. Now a sample space for this right here is considered compound probability because you have more than one thing happening, okay? You have two different things that you have to find the probability of and mold it all together into one, okay? So let's look at the sample space for this. Again, we're going to use our brackets like this. Now what we're going to do for the sample space is we're going to list out everything that's inside of our array. Okay, so the possible outcomes from this probability, this compound probability, is You can either get heads, heads. You can get tails, heads. You can get heads, tails. Or you can get tails, tails. So that is the sample space for this probability. And let's actually look at this with a probability model too. Okay, so we're going to have our outcomes on the top, our probability on the bottom. I know it's been a few days since we've done probability models. You might be a little rusty. That's okay. We're going to get you back in the groove here. Probability models are just a nice tool to make sure that all of your outcomes are nicely laid out and easily accessible. You can freehand all of these tables. You do not need to make nice, neat, precise lines with a ruler. It's just something that I do because I want your notes, I want you guys to easily see everything that I'm doing in my notes. Okay, so if you're going to make this table, you have outcomes and probability, and then you have all the sample spaces basically listed across the top. So we have the outcome that you would get, all the possible outcomes, and then the probability of that happening or occurring. Okay, so in our sample space, we have heads. Heads is one outcome. Tails, heads is another outcome. Heads, tails, and then tails, tails. Well, because these are coins and all the probability is equally as likely to occur, then we can say that all of these outcomes are the same. Okay, so this is one outcome out of 4. The same is going to be true for all of these. They are all one outcome out of 4 possible outcomes. Okay, so we can say that the probability of rolling heads, heads, or flipping heads, heads would be 1/4 or 25%. The probability of rolling heads, tails is, again, 1/4 or 25%. All right, so I'm going to show you another approach to this because some people really like just making lists instead of using arrays. So I'm going to show you how we can make a list and also an array for the same type of problem. Okay, so this time we're going to make a list. Of all possible outcomes when rolling 2 6-sided number cubes. Okay, so you have 2 number cubes. We've been using number cubes quite a bit, so hopefully you're ready to go on that. And if your red number cube is 1, then your yellow number cube could be 1. So that's one option. We're going to write it like an ordered pair. If your red number cube is 1, your yellow number cube could be 2. So this is 1, 2. It could be 3. So this is 1, 3. It could be 4. I think you're catching my drift here. It could be 5, or it could be 6. Now, if the red number cube is 2, then the yellow number could be 1. It could be 2. It could be 3. It could be 4, it could be 5, and it could be 6. And now let's say that the red number cube is 3. So if the red number cube is 3, then the yellow number cube could be 1, 2, 3, 4, 5, or 6. Same thing if the red number cube is 4. So hopefully you're catching my drift here about how this all is going to get laid out. We're assuming that the red number cube is the first number and the yellow is the second number. You might say, well, Miss Mack, this looks just like an array, and you're right. Okay, so this is a list because we don't have it all neatly written out as an array, but it is very similar to an array, and I'm actually going to do an array of this in just a minute too so you can see it. Oops, 5, 5, and 5, 6. And then this is the last row when that red number cube gets to 6 and the yellow number cube goes through all of its numbers. Sorry, I definitely got messy here because I was writing fast. My apologies. Okay, so now let's say that we want to write a sample space for the sums of those numbers. Okay, that's not the same as the sample space that we did above. So let me talk to you about it. And I'm actually going to kind of color code it a little bit too. Okay, when you add up to the number on the two number cubes, the smallest number that you would get is 2. Because there's only one time when it's rolled, and it's when you get a 1 and a 1. So I'm going to say that this right here is the only time you can get a 2 when you find the sum of the dies. So we're writing a sample space for the sums. We're not necessarily what combinations are here. So far we have a sum of 2. That's one possibility. What about a sum of 3? Well, you can see here we have 2 plus 1 or 1 plus 2. Both of these have a sum of 3. Okay, and we can keep going back and forth like this, but here 1 plus 3 is 4, this is 4, and this is 4. Okay, so 4. And you can see that these ones add up to 5. These add up to 6. These add up to 7. These all add up to 8. These ones right here add up to 9. These add up to 10. These two add up to 11. And this last one right here adds up to 12. So if you're finding the sample space for a number cube, you're going to have the numbers 2 through 12 in that sample space because that's what the sums that you can get by rolling 2 number cubes. Okay. Now let's flip our page over so that we can demonstrate an array for this. I'm going to flip my guided note page too. Okay, so let's actually create an array for the sums now, because this is going to be cool. Well, I guess it depends on your definition of cool, but I think it's cool. So we're going to create an array for the sums. Let me make sure my page is all the way on there. Okay, good. All right, so I'm going to set up an array. And I'm not going to take as much time as I usually would, so bear with me. It might not be pretty, but you know, we're going to roll with it. I'm just going to create some lines down here to create our array. One, two, three, four, five. We need 6 columns because we're talking about a number cube here. And we're just going to use the rest of these, just the lines that are on the paper to guide us. But I am going to do the top and the bottom. So let's say that we have 2 number cubes. One number cube we're going to list across the top. So for one number cube, you can roll the numbers 1, 2, 3, 4, 5, and 6. Now the second number cube, we're going to list across the side, and again, you can roll the numbers 1 through 6. I think this is so much easier than doing a list, but that's just me personally, okay? So now let's look at this array. All we're going to do is we're going to fill in the sums. So 1 plus 1, and actually I'm going to use a different color so it stands out, is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5, 6, and 7. Now the next row, 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5, and so on. And then 3 plus 1 is 4. This is 5, 6, 7, 8, 9. And then we have this. This is 4 plus 1 is 5, 6, 7, 8, 9, and 10. Okay, this is 6, then 7, 8, 9, 10, 11. 6 plus 1 is 7, then 6 plus 2 is 8, 9, 10, 11, and 12. Okay, so now that we have this array all done, we're going to actually use it now to answer some questions about probability. Well, actually, I think what I'm going to do is I'm going to list out the probability for each of these. Usually I would use a probability model, but I want you to look at it in a different way. So I'm actually going to write out the probabilities that can be found using this array. So what is the probability of getting a sum of 2? Well, if you look at this, getting a sum of 2 only occurs one time, and it's right there. So that means there's only one outcome that gives you a sum of 2 out of, there are 36 outcomes altogether here. So the probability is going to be 1 over 36. Now let's find the probability of getting a sum of 3. I'm going to use, let me see if I have a different color. No, I don't think I do. That's okay. I'll use my black pen. That will help us out. So you can see that there are 2 times that we get a probability of 3, right here and right here. So what that means is the probability that the favorable outcomes, there are 2 out of 36 possible outcomes, and we can reduce this to 1 over 18. Now let's find the probability of rolling a sum of 4. Okay, so when I look at this, I can see that 4 occurs 1, 2, 3 times out of 36 possibilities. So my probability when I reduce this is going to be 1/12. Now let's do the probability of 5. So, I'm getting ahead of myself. If you look at this, 5 occurs 1, 2, 3, 4 times out of 36. So this is going to be 1/9 is the probability. Now let's do the probability of getting a sum of 6. It occurs 1, 2, 3, 4, 5 times out of 36. Then the probability of getting a 7, so 1, 2, 3, 4, 5, 6 times it occurs out of 36. So this is going to be a probability of 1/6. So notice that 7 is the exact diagonal of this array. 7 has the greatest probability of being rolled as a sum. Okay. And then after that, we're going to basically be going backwards along our list because look at 8 has 5 different possibilities just like 6 did. So the probability is going to be 5 over 36. Then the probability of rolling a sum of 9 is 1, 2, 3, 4, just like it was for this one. So the probability when I reduce it is 1/9. Then you have the probability of 10. Happens 3 times out of 36, which is 1 over 12. The probability of rolling an 11, it happens twice out of 36. So this is going to be 1 over 18. And then the probability of rolling a 12 is 1 out of 36. All right. So you can see why I listed it out like this, but you could easily use a probability model for this, and it would be a lot neater and easier to follow. So that's actually why it's important to use probability models. It definitely organizes your information in an easier to understand way. All right, Bobcats, we're going to go ahead and end with this for the day. Check in with your teacher and make sure you don't have anything else to do before you leave today.